Yeah. Mm-hmm.
So there are two topics I would like to talk briefly during
Mm-hmm.
these 20 minutes, which are first is related to the blueberry systems.
Mm-hmm.
If we go to the work document,
Okay.
I'm just gonna, one moment. I put a new slide, the number one. Well, no, sorry, number five, which is the biggest leverage for getting near zero marginal cost blueberry
Mm-hmm.
system. So we have seen different costs on, let's say, the structure. We saw that maybe, yes, doing Burnett and Sunshade, it's the highest cost per plant. But if we talk about leverage and compounding effects, I would say that there are other activities that should go first because of the leverage and compounding effect that is going to get into the system being into zero marginal cost. That's why I made this new analysis. So if we talk number one, which is high impact on CapEx,
Mm-hmm.
CapEx, and high impact on OpEx,
Mm-hmm.
that's fertigation and recirculations. We're talking about the irrigation systems, but also being able to recover the drainage and reuse that water. Why it's a compound effect? Because one, if there's full control and recirculation of the water, maybe we don't even need to have sunshade as an example. Why? Because we're able to put water and recover it many more times without being an added cost. And that's going to be a plant that is going to be in a better condition just with the use of water, as an example.
So you can get away from shade cloth by using more water.
That was an example. I would say I cannot answer it with every variety and plant, but maybe on certain plants and certain treatments with constant water and control water quality, I would say there's an opportunity because I
Uh-huh.
did it 2 years ago here in Obregon. I had a section without sunshade and one variety called Gladiator. It gave first 8 months 3.5 kilos, and the size of the fruit was at least 19 millimeters. That's one of the University of Georgia. But going back to the point, is yes, it's possible with certain varieties. Plus, the good treatment of constant water and quality control of the water that it's getting, that could be a certain plus to achieve it totally.
If you went to the different variety, would that work for you and you'd quit the variety that you're testing mainly? Or no? Or you're hoping that the main variety that you like will survive with the same treatment. What more water? Will thrive with more water.
Yes, I believe that that's going to happen if it's in better conditions. I mean, some varieties they don't get so much resistance to heat, but also to water quality variations. So if there's a perfect control of
Mm.
the pH and the electrical conductivity, a lot of varieties that didn't hold so much heat, they're going to hold it now because they're in better conditions.
Will the if you cannot make your main choice work with that, will you switch to another, or no? You still you just quit that idea and return back to shade cloth.
Yes, I would switch to another. All would be based on cost and quality of the output of fruit that can be
Uh-huh.
done. That's why I'm trialing at least 14 varieties as of now.
Huh. So the shade cloth part is so expensive that it could make sense to do a lower yielding or lower quality. Like, does the other one yield less? No, just different quality. Will you get the same premium market or no?
Oh, sorry, I think I didn't answer the question correctly. What I meant is if one variety didn't work out with the system without the sunshade, if I would be open to switch to another variety. That's what I understood. But no, I want to stay with a variety that gives enough output of premium jumbo blueberries. That's the goal. High
So the
yield and high quality.
so in other words, the one that you're trialing right now, that one has to work. You're saying if it doesn't
Yes,
work with water, you need shade cloth.
correct. Or it
Okay.
can work much better with shade cloth.
Yeah. And it's possible that you might take a little hit without shade cloth, but because of the cost, it could be. So you have to, work out those exact numbers and all that.
Correct.
Okay,
I
I see.
say it's always better to have less risk. And that's the point of the shade cloth,
Okay.
to have less risk.
So are you giving up shade cloth at this point or no? Are you still going with it?
I'm still going with it, but I would say with adaptations like the ones we talked before of
Mm-hmm.
have it on single specific square meters,
Mm-hmm.
not the
Mm-hmm.
whole hectare covered. With that adaptation, that's a possibility. I'm just gonna keep reading the rest of the concepts to go in order which I see the biggest priority to the ones I see a priority, but not the biggest one. So
Okay.
we talk about fertigation and recirculation.
Mm-hmm.
Then it comes the harvester, the mechanical harvester, because one of the biggest costs when we talk about scale,
Mm-hmm.
it's labor for harvesting.
Yeah.
So instead of thinking that I have to make the substrate first or the pot,
Mm-hmm.
I would think first, how do I develop a harvester for this specific system? They're already in the market. That's the one we saw that called air
Mm-hmm.
harvester, which I think
Mm-hmm.
it's very good for pots. It just on the scale, I would need a lot of those harvesters, and they're at least 120,000 USD
Okay.
per each. That's why it's high leverage. Then it comes the pot and the substrate, which we have talked and work about, the biochar and filament. I think
Mm-hmm.
that's an amazing idea that I wish to keep going on. Then it comes the farm geometry and mechanization. So this could be the certain sunshade structure. This could be doing the bird laser instead of doing the bird net. And this could be develop certain,
Yep.
yeah, certain how guide for the plant. So we're able to harvest mechanically everything of the fruit that is on each branch. That's what I meant by farm geometry. Then it's energy,
Oh,
solar.
hold on. Geometry refers to. How does that have anything to do with 100% harvest?
I meant geometry of the plant.
Oh,
So if
plant
there's
geometry. Okay.
yeah, if there's a need to prune it certain way, we can do mechanical pruner. If there's a need to put it on certain structure, we can think about certain trellis.
Farm geometry means plant geometry.
I would say both
Oh, okay.
because farm, we're also talking about the structure for the sunshade.
Layout of, like, for example, circular versus linear, whatever. That's also you want to explore some optimizations regarding exact, rows, columns, that kind of stuff.
I would say no because thinking on the mechanical harvester, that really benefits from straight lines.
Yeah.
That's the best efficiency that can have. So those are the main categories. At last, it's an ERP and data stack, how to manage all the information in order to take better decisions. But I think that's very developed on the open source.
Yeah. Does this table now refer your priorities as you'd like to do them now?
Yes, I would like to focus first on the fertigation and recirculation, then go air harvester, and then pot and substrate, and
Mm-hmm.
then farm geometry. I would say that should be enough for 4 years.
Uh-huh. First three or first four?
First three.
First three. Okay. Do you want to go with them all at the same time or one at a time?
I want your advice to really be able to make this happen.
I would, I like to bound the problem. If that's the problem, you always kind of have, you don't focus on one. You keep the potential ecologies and product relationships between them always alive in your mind. That's how I would think about it, because I bet you that, well, I mean, it's all going to be related. Like, for example, all of them are going to be relying on 3D printing for parts. So when you talk about this, you might want to be talking about a construction set approach. Once again, let's break this into modular components and see how much overlap you have altogether, because there's going to be common overlap. So now you want to break this down into parts. Literally, like, I don't know if you like, do you like visual thinking, like icons?
Yes.
Yeah, icons. So break down each system into a load of icons, as many as you like, and then you'll start seeing that there's a lot of the same ones, and you try to break it down as much as possible, because if you go down to the lowest possible, you'd have 100 icons total, or maybe 20, which is the elements in the periodic table. But no, we're not going, that's extreme. But break it down into as many things as possible to the point that you see increased overlap. And then you can start treating this as a system. So you're learning to be a system engineer. I don't know if you consider yourself one already. You're a systems integrator, right?
Yes, correct.
Yeah, you're a complex system engineer. It's not like engineers. Yeah, there's a whole story there. But engineers, wow, that's like the way engineering is done is like you got one thing, but it is poor if that's all an engineer thinks about. You got to think about the system. So it's system engineering. Yeah. Cool.
Okay, that would be one. I would just focus first on fertigation and recirculation, doing each component, cost, design, mechanics, and then I can show you, and we'll go from there.
Yeah. And you have you ever seen the 500 modules page?
No.
So there's a page on when I look at the Techosphere, the Global Village construction set is 50 machines, but if you start breaking those down, you've got, say, a dozen modules per: frames, engines, mechanics, controllers, etc. But common to a lot of those modules is the more primitive modules that are 500 modules. Just take a look at that. Let me put a link in there. See if we can actually that page is like a mess. It's an initial list of some of the most key elements that all mechanics and all technology is made of. So for example, I mean, basic stuff. Here's a spring, here's a shaft, here's a bearing, that kind of stuff at that level. I think that is useful, because then you degenerate the design into common, like for example, a shaft or a bearing. You're gonna end up with a construction set, meaning the minimum types of variations. Because like right now for a bearing, you'd have like 100 manufacturers, all kinds of different things. But we're degenerating into a smaller set so that as many of these parts are used between the systems. So when you design a system, you are taking the parts and trying to use the same part, because that has a big implication on maintenance. You know? Like, for example, to give you one example that emerges from the building work, 2x6 lumber, for example, and oriented strand board OSB sheeting. You can make like 10 by 12 structures with a part material count of 2x6 and OSB. That could go for the roof, floors, walls. If you went more than 10 feet, you would need like 2x8, for example. But so you want to look for patterns where you can design it in a way where the lowest amount of, that's an example of a construction system, like building structures with just 2 parts, right? That's great. You have to worry about 10 parts. That's, it is a game changer. So think about it that way, just theoretically speaking. When you design this, think about this. So I'm going to edit that 500 modules page on the wiki. I like this kind of a thing. Like you told me that you like the idea of bounding a problem. Well, the 500 modules is a way to bound the entire Techosphere. Everything. So let's take a look at what they are. So when I go to that page, this is where I'm taken. Maybe you can start editing that, but I mean, here's like a lot of things here are, yeah. I mean, just go through it. I think it's a useful exercise, and this is not organized. This is like first cut. So start maybe organizing that for an agriculture set. You know, like what are the parts that are highly relevant to agriculture, or whatever, however you want to organize it. Feel free to, like, you know, edit this and all that. Let's see, what do we got here? That's there's a lot of stuff there. But once you start breaking it into, like, for example, that the mechanical harvester, I bet you're going to have a solenoid valve in there. And I bet you're going to have a solenoid valve in your watering system. And let's see, what's your other system? Air, pot and substrate. And I bet fertigation, yeah, absolutely, solenoids are going to be there. Pot and substrate, well, yeah, unless they're part of fertigation, they're highly related. So I'm just saying, look for common ground. Like you mentioned, 3D printing. It's highly generative. It'll work in all these things. Yeah. So I would say do a modular breakdown. So now, take it like one of the 50 machines. Do a modular breakdown. Start breaking it down into as many parts as you can, so that what do we have for modular breakdown on the wiki? Module-based design. That's good. So you're getting focused on top priority areas. Let's see, where's our list of modules?
Are you looking on the wiki?
Yeah, I'm looking at the wiki. Let me get you a link to the module-based design page, because you definitely want to use this concept. You've seen this before. I've talked about it. Module-based design. It's such a generative approach. I mean, do you feel it? You agree with that, or yeah? I mean,
Yes.
yeah, absolutely. So take a look at that, and I want to show you, like, what's the typical breakdown. Where is our list of modules? Oh yeah, I mean, definitely look at the construction sets page, construction set approach. Because if you're going to scale things, you can do intensive or extensive scalability. Extensive means that you just multiply the absolute same unit. Intensive is where you actually make it larger and you have to re-engineer it.
Got it. Working for the extensive way.
Yeah, that's the easier way. For intensive, it's harder, because you got to do more calculations, and some things at certain scales change. Like, you got to kind of modify the design to make it work. Like in a business, a solo operation is not a 100-person operation, and a 100-person operation is not a 10,000-person operation. They're very different entities, right? Same thing in in scalability of technology. You go to like a different regime unless you are following extensive scalability. Yeah, construction set approach.
So the goal for next week would be absorbing this information and apply to the fertigation and recirculation.
Yep, break it down and start breaking your thing into modules. If you can, come up with simple icons so we can move icons around.
Okay.
We've seen Have you seen the open source technology pattern language page?
I can remember that information.
Okay.
But I'll take a look as well.
Yeah, it might give you some insight of how you now start. If you say you're a visual thinker, then, and you are a visual thinker, right?
Yes.
Yes. If you're a visual thinker, use icons and move them around to do your design. You don't have to do it with words, right? How do you go about design? Well, if we're communicating designs in diagrams, icons are a great way to do it. Yeah, I think. Yeah, definitely. Because like for example, you give me that icon, give me 20 icons. We can actually start physically in a Google Docs, Google Slides, start arranging them, and they actually start making sense. Or maybe we substitute icons. You can move icons around to actually reflect the geometry of something, or they help you understand something more quickly. Yeah, it's a diagramming thing. It's like a mind map thing.
Could I do just a direct picture since we're talking about
Yeah.
replication through open source? Maybe
Yes.
just the current design. That would be a good visual.
Yeah, you mean a picture, an icon for the whole thing?
Yes, I mean, right now I'm thinking about droppers from the irrigation system. So I have current droppers on my farm, which I could just take a picture, and that could be the model
Yeah,
to understand.
exactly. Graphic stylize it so. Um, let's talk about graphic style. It's as simple as, yeah, take a picture, put a border around it, and like it's your icon. But they have to be. The thing is, it has to be uniform, right? It's the more uniform, the better. Like for example, if you look at I wanna
I
do
can
this.
get it from the information that it comes on the each product. It has like a technical data sheet. It has some pictures, and from the
Exactly.
same supplier I'm working with, I can get the same style. If that's
Exactly.
what you mean by continuity on what the design is being.
Mm-hmm. Or as simple as you got a screenshot, just like in visual bills of materials. You got a screenshot, blue border, it's a hyperlink to an actual part. You can use those as icons too. So you can design with, the VBOM, the visual bill of material
Yeah.
concept. Yeah, do stuff like that. That makes it, you can start rapidly designing this in that way. And the thing is, CAD bomb build, right? That's that trio thing. I talk about that. Each of those, CAD is reflex design, bomb build. Each of those should be a complete description. Like if you have the full CAD, it should in principle give you all the information. If you have the BOM, it in principle gives you the complete design. If you have build instructions, that in principle gives you the complete design because you have to describe what you're doing. So those things are interchangeable. So think about all those being interchangeable and useful.
It's okay. I'll work on that system information design.
Yep. Next time, let's talk about, break it down. Start breaking down into parts. I would do 2 steps. One is the general modules. Like if you do fertigation, that's kind of interesting. Fertigation, recirculation. Well, containers, pumps, tubing, those are like your main modules. Start with the very simple ones and then try to see if once you got like around a dozen of the main components, start detailing each and like what maybe each one is made of until and go as far as you can and that way you actually will get a complete design. Initially you won't have all the parts because once you have a module you start thinking, well, okay, how am I going to actually implement that module? And there might be several choices. So that makes you go to the next step, which is, okay, now let me reevaluate the choices and stuff. And of course, use. I mean, start with chat. Just give me the breakdown of the system and stuff, or tell. Oh yeah, give me a modular breakdown. Just do that first and see if it helps any.
Okay, I'll work on that. I know we're over time. Just a quick question when the second topic is I'm working on a project for doing freeze-dried ingredients, specifically citrus, blueberries, and make it into a fine powder. So there's already that technology. The only concern is it uses a lot of energy, and that makes the cost high.
Whoa.
I'm talking to you because of the thermal storage battery, because of the PV knowledge you have, and because of the design of the thermal battery. Maybe the freeze dryer, the common
Holy cow.
design worked with electricity, but this could work with the hot or cold water. The thermal storage battery could develop for each process. That's what I want to achieve as well.
Holy cow. So
But
where did you?
we can do it now or next call. You let me know.
Holy cow. Now, where'd you get? Did you get that from me or did you get that from you?
The
Freeze dried fruit powders?
Do you mean if I get it from where?
Where'd you come up with this idea to do that?
I've been trying to do eliminating food waste on my farms for many years, and this is one of the processes I've been dealing with. But the energy part, I got it from you.
So you tell me you did not hear me talk about freeze dried fruit powders?
No.
I've been talking about that for 20 years. That's one of the first things. I think we're thinking similar ways because that's the same thing I say. For one, it's called the replacement to Coca-Cola. So this is a billion or trillion dollar industry, right? And second of all, yes, you have permanent storage of that which could go to waste. So I love it, man. Yeah, we'll get. Let's talk about it next time. That's exciting.
Sure.
Yeah, let's talk about. I'll get stuck and I won't get rest for tomorrow. I gotta go. But no,
Yes.
that's amazing. I can't believe yeah. I mean, you're thinking about all the pretty much the same stuff that I've thought about, and
Amazing.
it's awesome.
Glad to hear that. We'll talk next call. I think the market is there. I don't think I know the market is there, but it's just getting a low cost in order to be able to make it scale big. Right now, super expensive to get it on wholesale, even consumer wise. So maybe your strategy of energy could change everything
You're talking
regarding the
about
cost.
freeze-dried fruit powders?
Current freeze dryers, they're high
Yeah.
cost, a finished product. Your energy strategy, thermal battery, and design based on that could change the cost of freeze dried powders.
Yeah, but I would say isn't it that the limit there is the technology, not so much the energy?
Depends on your point of view. If you talk about formulator market and you tell them you can get them this same ingredient with same quality at lower cost, the opportunity of doing freeze dried products is going to scale a lot, and there's going to be
Okay.
a market profit with what
So
was going to waste.
yeah,
Yes.
no, that's great. I think the bottom line is that the answer is already there. Everybody uses expensive energy. Once you go to solar, that at current prices, that's a game changer. So one thing I noticed about solar is that given that the PV is going down so much, solar electricity hasn't. And that's like one of those weird things. But that's a thing we've got that in a bag. So yeah, so I say I'm actually probably more ambitious regarding the freeze dried fruit powders because I mean I believe that's the transition to actually healthy drinks. Like right now junk drinks predominate. This is a chance to actually heal the world from all this disease that junk drinks cause because yeah, this is big. That's big. So I love it that you're thinking about it. So yeah, okay, more common ground. Okay.
Let's talk about it next call.
Yep.
Thank you very much for your time, and I'll see you soon, Marcin.
Okay. Yep. Take
Bye.
care. Bye bye.